exponential functions. Then just to find the value of each. So the first one here wants us to find 4 raised to the negative 2. Please remember when you raise something to a negative power that you drop it to a denominator. Therefore, that would be 1 over 4 squared, which happens to be 1/16. The next one wants a 4 raised to the x, so 4 to the 5th power. 4 to the 5th, you would just type in 4 times 4 times 4 times 4 times 4. Therefore, 1024. The next one wants 4 to the 2/3, and it wants us to simplify the answer. So to first off, that means the 3 on the denominator for the exponent means the cube root. So that's the cube root of 4 squared. Now, 4 squared is 16. Now I need to know if this breaks down. If I was to do the birthday cake for 16, 16 would be 2 times 8, which is then 2 times 4. So 2 times 8, which 8 is 2 times 4, which is 2 times 2. You guys, the cube root, I would be looking for triples. See, there's a triple set of those, so I take this one out and left with one on the inside. So it'd be the 2 cube root of 2. So we're supposed to graph a half to the x power. So we want to make tables of points. Again, you want to take that exponent equal to 0. These will all be with no calculator for these graphs. So I need a half to the 0 power would be my first thing I would do. So anything raised to the 0 is 1. Then, if I did 1/2 raised to the negative 2 right here, that would become 1 to the negative 2, and on the bottom, 2 to the negative 2. Well, the 2 to the negative 2 comes up, it's 2 squared, and that's where I get 4. All right, 1/2 to the negative 1. Well, that would be 1 to the negative 1 over 2 to the negative 1. Again, bring that 2 to the negative 1 from the bottom to the top, and that's where we get 2. The next one would be a half to the first power, which is a half. Next one is a half squared. That means a half times a half, which is a 4th. And then you can go along and plot those points, and you'll have your graph. The asymptote was y equals 0, because even if I took 1/2 raised to the 10th power, it'd be 1 over whatever 2 times 2 times 2 times 2 times 2, 10 of those. The number will be very close to 0, but it will never actually approach it. It just gets close to it, never actually equals it. Even if I took a half to a million power, it would be very, very close to 0 again, but still will not actually touch it. The domain goes left and right forever, so it's still all reals, but my range, it never touches 0 to infinity. So the lowest it goes was 0, but doesn't include it, up forever, so infinity. So this graph, the opposite of 3 to the x power. So again, this parent function would be 3 to the x, which looks like that. The negative in the front would flip it over the x-axis, hopefully you were thinking. So the graph will look something like this. So we should at least know kind of what the graph should look like. Again, you will plug in your numbers. Anything to the 0 is 1. So 3 to the 0 would be 1. Then that would be the opposite of it, which would make that negative 1. If I tried negative 2, so 3 to the negative 2, that would be 1/3 squared, if I want to make that a positive. So therefore, again, 3 to the negative 2, we brought the 3 squared to the bottom, and that's where the 9 came from. 3 raised to the negative 1, 3 to the negative 1 would be 1 over 3 to the first power on bottom to make that a positive 1. So that's where I got negative 1/3. If I plug in 1, 3 to the first is just 3, and then I have the negative 3. 3 squared is 9, and then that's the opposite of it, so negative 9. And the blue graph is the final graph. Domain is all reals, but my range goes how low on the blue graph? Down forever, but up to, but not including the 0. This time I would take the graph of 3 to the x, but then I'm going to shift it to the right 2. This is with the x. It'd be like that was in parentheses, so it has to go to the right 2. So the parent function 3 to the x, and we're going to take and shift it a horizontal shift of 2. So some of your graphs are going to be with the words, and some of your graphs will be you have to make a table of points, and then you find the multiple choice graph. So it just depends on what the problem is. So if it asked you to make a table of points, again, take the exponent equal to 0, so x equals 2 in the middle. 2 minus 2 would be 0, 3 to the 0 would be 1. Now if I plugged in 0, that'd be 3 to the negative 2. Remember, if it has a negative exponent, just bring it to the bottom. That'd be 1 over 3 squared. So that's 1/9. 3 to the 1 minus 2. 1 minus 2 is negative 1. 3 to the negative 1, bring it down. 3 to the positive 1 on bottom, so 1/3. Take it to the third power. 3 minus 2 is 1. 3 to the first is 3. Take it to the fourth power. 4 minus 2 is 2, so 3 to the 2 is 9. And again, some of the problems in your test and homework ask you to fill in these y values for the table and then a multiple choice graph. Some of them you're using the parent function and then you're doing all the shifting, horizontal shifts, vertical shifts, and so forth. So this would be the graph of 3 to the x again, but this time it's going to be a what kind of shift? Hopefully you're thinking a vertical shift of -2, shifting it down 2 units. So 3 to the x, vertical shift, -2. If it's the kind where you have to make the table of points, you're going to take the exponent equal to 0 in the middle, so x is 0. So 3 to the 0 would be 1 minus 2, 3 to the 0 is 1 minus 2. This should say -1, so I'm sorry about that mistake, y'all. This right here should be a -1. Please fix that in your copy of your notes. All right, plugging in the -1s, this would be 3 to the -1, would be negative, this would become 1/3 minus 2. Plugging in the -2, 3 to the -2 would be 1/9 minus 2. So 1/9 minus 2, 1/3 minus 2. Plug in 1, that would be 3 to the first is 3 minus 2 is 1. Plugging in 2, 3 squared is 9 minus 2 is 7. And then those would be the points that you plot. And again, like I said, this one right here, 3 to the 0 should have been 1 minus 2. That right there should be a -1. Domain, it does go left and right forever, but for my range on this blue graph, it goes as low as, but not including the -2, and then up forever. So that's why the range is -2 to infinity. This one in the homework system to graph it was a little bit more complicated for students, so I've added this one onto the notes. So again, the parent function would be the 1/7 to the x. If you have a -x for x, what does that do to your graph? See, a -x for x is going to flip it over the y-axis. So here's my original 1/7 of x. Again, if the base is smaller than 1, that's going to be your original graph. A -x for x is going to flip it over the y-axis. So reflect over the y-axis, we will now have the green graph. Now, I take what's right here in the this exponent equal to 0. That would give me x equals +5. That's going to make it shift to the right 5 units. See, if I factor out the negative for that x right there, that would give me x minus 5. See, that's going to be to the right 5. So therefore, a horizontal shift of 5, the purple graph, is the final graph. Now, if this one makes you plug in points for a table of points, you plug in the 5 first. So -5 plus 5 would be 0. 1/7 to the 0 would be 1. Points around that. So let's say I started with the 4 next. The opposite of 4 would be -4 plus 5. Well, that would be 1. 1/7 to the first would be 1/7. Plugging in 3. -3 plus 5, that would be 2. 1/7 squared would be 1/49. 6. Opposite of 6 plus 5, that'd be a -1 up here. A -1 for the exponent, flip this, so that becomes 7 to the +1, which would be 7. And then plug in 7. -7 plus 5 is -2. So 1/7 to the -2. Flip it over, so 7/1 to the +2 then. 7 squared would be 49. And you should notice, like, these all multiply by something or they all divide by something. There's always some sort of pattern there. Okay. I think that's the end of the graphing, but now we will move on to solving. So use your properties to solve using for exponents. What you want to look for here is, can you get a common base? 5 to the x and 125. 125 is 5 to the 3rd power. It's 5 times 5 times 5. So 5 to the 3rd on the denominator, if you bring it up, that's 5 to the -3. Now, these both have the same base, therefore x equals -3. So can I write these with the same base? See, 3, base of 3, 9 would be 3 squared. So this exponent's x plus 1. This exponent becomes 2 times the quantity of x minus 3. So I set those equal. Distribute 2x minus 6. Subtract subtract the x over, add 6 to this side, and we get x is 7. Again, you want to write these with the same base. This one looks like I can't do it the same base, but we can. See, the square root of 3 means 3 to the 1/2. 9 means 3 squared. So we can still write that with the same base, even though it doesn't look like it. So again, 3 to the 1/2 for the square root. 9 happens to be 3 squared. So now I've got 2x equals whatever a half times each of those is. So therefore, I go ahead and subtract the 0.5x from both sides. Divide both sides by 1.5, and that would give me 5/3. So solving this one, b raised to a power. I need to get rid of that power. So to get rid of the power, I want to raise both sides to the 2/5. That means 2 over 5. So if I take the 5 over 2 and raise it to the 2 over 5, those two multiply to give me 1. That's why it's just b. Now, because this is an odd root, I don't do plus or minus. If that was an even root, I would have to do plus or minus. So therefore, I'm going to take the 5th root of that, which is 3. 3 squared is going to be 9. If I was to check it and plug 9 back into here, that means the square root of 9 first, which is 3, and 3 to the 5th is 243. Okay. These will be with a calculator. These will not be on my test, nor will these be on the final. Your final exam is no calculator. So again, for this part here, you do need to use a scientific calculator or a graphing calculator, whichever you happen to have at home. If you don't have a graphing calculator at home, if you take your phone's calculator and turn your phone sideways, it typically will take it to a scientific calculator for you. It'll just take a little bit of time probably for you to get used to using it, because a lot of times the buttons will be backwards. So just bring your phone in with you to class, and I will help to show you where some of these buttons are located on your phone for you. All right, the formulas that you're going to need for this are: suppose $2,500 is invested at 6% in an account for 10 years. We want to find the amount of the money and at the end of the 10 years if the interest is compounded quarterly, monthly, daily, or continuously. So all three of these use this formula here. It's the principal amount times the quantity of 1 plus the rate of interest over n, the number of times a year it's compounded, raised to the n times t. And t meaning the number of years it's in the account. Continuously, we will always use the formula y a equals a pert. I call that is the principal times e raised to the r times t, or r is the interest rate and t is the time in years. So quarterly would mean that it's been compounded 4 times a year. So notice there's a 4 here for the quarterly. All of these are for 10 years, so all of the t's will be 10 years. The interest rate for every one of them was 6%, so 0.06. The principal amount invested for all of them was $2,500. So you literally just go ahead and type it in and get your answer. And again, if you don't know how to type this into the calculator that you're using at home, please bring your calculator with you, because I need to show you how to get these answers on your calculator. These are on the ACT and the SAT test. All right, if something is compounded monthly, we would want our n to be 12. If it is daily, then our n would be 365. And then continuously, this is the e on the calculator. And it should be above the natural log. So 2,500 times e raised to the 6% times 10. And notice each of those amounts got a little bit larger all the way up until compounded continuously. It says, find the present value that will grow to $15,000 in 8 years, compounded annually at 4.8% interest. So we want to find the principal amount that will grow to $15,000 will be the amount in the end. The interest rate of 4.8%, compounded annually would mean once a year for 8 years. So we need to solve this. Well, if I go ahead and get this decimal answer right here and then divide that into, again, this is all still with the graphing calculator or scientific calculator. So we go ahead and get this decimal, that's 1.048 to the 8th power. We divide by it because that's times p. So I just need 15,000 divided by this number, and it would be approximately $10,308.63 in your account. That would grow to $15,000 in 8 years if it's compounded annually at 4.8% interest. So this time, if only $10,000 is available to deposit now, that's my principal. What annual interest rate? I'm trying to find R. For my money to increase to $15,000, that's going to be the A. In 8 years, that's T. So the first thing I hope you can figure out is which variable. So again, A was the amount in the end. P is the principal amount we start with. R is the rate of interest we don't know. Annual means once a year. T was the time in years, which was 8 years and once a year. So first I should do here is divide by 10,000. Then I want to get rid of this 8. So I would do both sides raised to the 1 over 8 power. That gets rid of the 1/8. Now after I've done that, then I would minus 1 from this answer, and that would give me my interest rate of 5.198%. And now if they told me to round to 2 decimal places, then that has to become 5.20%. So the problem must have said to round to the nearest hundreds there. So again, these two formulas, okay, any of them that involve these two formulas are not on your test, but they will be in your homework. They're not on the final exam. You do need to have exposure to them. Some of you may go into the business world and you need to know those formulas. Our exponents and our properties today, the exponential functions, the exponential equations, we wrote things with the same base, don't forget. Compounded interest is what we've just done here. Hope this helped you guys out. You have a great day.